Supports are the part of 3D printing everybody gets wrong first, because the instinct is to turn them on for everything, and that is almost always the expensive answer. A printer builds a layer at a time, and every layer needs something underneath it. Supports are scaffolding for the parts of a model that would otherwise be printing into thin air. So this covers what actually needs support, the two main types, and when each wins, the settings that decide whether they come off cleanly, and how to design so you need far fewer. Chapter 1: What actually needs support. The rule people quote is 45 degrees, and it is a decent starting point. Below about 45 degrees from vertical, each layer is still resting mostly on the one below it. Push past that, and each layer hangs further out over nothing, until the plastic droops before it can cool, and you get a rough, sagging underside. But that number is not a law of physics. It depends on your cooling, your layer height, and your material, and a well-tuned printer will often manage 60 degrees cleanly. The much more useful distinction is between an overhang and a bridge. An overhang is unsupported on one side. A bridge is anchored at both ends. Bridges are far easier because the plastic is stretched between two fixed points and pulled taut. Most printers will bridge a surprisingly long gap with no support at all. Chapter 2: The two types. Normal supports are vertical pillars that grow straight up from the plate or from the model, directly under whatever needs holding. They are strong, they are predictable, and they take a lot of material. They also touch a large area of your model, which is exactly where the surface damage comes from. Tree supports instead grow a trunk beside the model and reach in with thin branches that touch only at the points that need it. That uses far less filament, prints faster, and leaves much less marking, because the contact area is a fraction of what a normal support would use. The trade is stability. Tall, thin trees can wobble or fall over, and they are worse at supporting a large, flat area, where a solid block underneath is genuinely better. So the rough rule is trees for organic shapes and figures, normal supports for large, flat overhangs, and anything mechanical with big square surfaces underneath. Chapter 3: The setting that decides everything. There is one number that matters more than all the others put together, and it is the gap between the top of the support and the bottom of your model. Too large, and the support is not really touching, so the overhang droops anyway, and you paid for scaffolding that did nothing. Too small, and the support fuses to the part. It will not come off cleanly, and you will tear the surface getting it away, or not get it away at all. The right value is usually close to one layer height, so about 0.2 of a millimeter on a standard setup, and it is the first thing to adjust when supports are painful. The second setting worth knowing is the interface layer. That is a denser raft printed just at the top of the support, right where it meets your model. It sounds like it would make removal harder. It does the opposite. A dense interface gives the overhang a proper surface to land on, so the underside is smoother and the whole interface peels away as a sheet. Chapter 4: Where they go. Most slicers offer supports everywhere, or supports that only touch the build plate, and that second option is worth understanding. Plate only means no support ever lands on the model itself. Anything overhanging above another part of the print simply does not get supported. That sounds like a limitation, and it is often exactly what you want, because supports touching the model are the ones that damage surfaces you can see. For a figure standing on a base, plate only will support the underside of the base and leave the raised arm unsupported. Whether that works depends entirely on the model. And the best control of all is painting them on by hand, which every modern slicer now offers. You brush support onto the areas you want and block it everywhere else. Chapter 5: Removal and the damage it does. Take supports off while the print is still slightly warm from the bed if you can. The plastic is marginally less brittle and it snaps away more cleanly. Use flush cutters rather than fingers for anything near a surface that matters, and cut rather than pull, because pulling takes a layer of your model with it. The marks left behind are shallow. A light sand with a medium grit, then a finer one, removes almost all of it on flat surfaces. If a support genuinely will not come off, that is a diagnosis rather than an accident. Your gap was too small, and the fix is in the slicer next time, not in the pliers today. And if the support marks are on a surface that will be visible and matters, the real answer was to orient the part differently so that surface never needed support. Chapter 6. Needing fewer of them. Orientation is the biggest lever, and it is free. Rotating a part by a few degrees often turns a steep overhang into a gentle one and removes the need entirely. If a part has a large flat face, putting that face on the build plate usually kills most of the support requirement in one move. When you are designing the part yourself, a chamfer is the single most useful trick there is. Replacing a flat overhanging ledge with a 45-degree slope means it self-supports. The same applies to holes. A round hole printed horizontally has an overhang at the top that will droop, but a teardrop or a hexagonal hole self-supports and still takes the same bolt. So judge overhangs rather than trusting 45. Use trees for organic shapes and normal for flat. Set the gap near one layer height, turn interface layers on, and orient to avoid it. The thread running through all of that is that supports are a cost. Material, time, surface damage, and removal work all paid so that one region of the print can exist. Which is why the best support setting is usually the one that lets you use fewer of them, and the best fix is often a rotation rather than a setting at all. If this helped, subscribe to Layer Logic. There is a companion video on the support settings themselves if you want the specifics.